Okay, today I'm going to share with you the completing the square technique. Okay, so this technique is usually taught in Set 3, while some of the IP school, they learn it in Set 2. It is a very important technique, not just used to solve quadratic equation, but usually used in proving, and even until A level, it is still tested. And completing a square can come out anywhere as long as quadratic equation is involved. So it's a very versatile kind of technique, but a lot of students find it difficult. So today I'm going to break down completing a square with you. Right, completing a square actually can have 4 levels, I would say. So let's look at the easier one first. The easy one will be, I just give an expression x squared plus, let's say 4x. Okay, plus 5. I ask you to rewrite it into completed squared form, namely a times of x minus h squared plus k. Right? Sometimes we say this is the Hong Kong formula because h and k give you the coordinates of turning point. Right? Why is that so? Because very simple, square is not negative. So let's say in the event a is positive, right, this expression is going to have a minimal value because it's a U-shaped graph, right? So if a is positive, the smallest value that the square can take will be 0. So when does this happen? This happens when x equals to h. So when x equals to h, what happens is I have a times of h minus h squared plus k. So it's going to be a 0 in front, so this is just k. That's why h and k give you the coordinates of the turning point, and this is the minimum point when a is positive. So on the other hand, when a is negative, that will be a maximum value. Right, so complete a square is really important to help us figure out the coordinates of turning point. Therefore, we can see the range of the equation. We can see the maximum and minimum value. So that is actually the main function of completing a square, not in solving, because we have quadratic formula, which is derived using completing a square. So since we have the formula, we actually seldom use completing the square to solve any equation, unless the question forces us to do so. So most of the time, the question will give you an expression like this, or sometimes a function y equals this, and they ask you, can you do a completing a square on it? Okay, so what we do is, number one, group the first 2 terms together. Okay, you decide what number to add, right? So don't forget, right, this should be the a squared plus 2ab plus b squared identity, right? When the first term is x squared, a is x, means the 4 is 2b. So I need to add b squared, and 4 is 2b. So the number I'm going to add is definitely a 2 squared. Usually I won't write it as a 4. I will make it 2 squared because later on the next line I have to factorize it anyway. So might as well just keep it 2 squared. So I add this. This is not fair. I must immediately minus it away, right, to keep it fair, because otherwise I change the expression. So I plus 2 squared and minus 2 squared in the bracket. So let me slowly move the minus 2 squared out of the bracket, right, such that the first bracket is just a perfect square identity, while the number at the back, I can actually just use a calculator. So I'm done. So this is the completed square form. So if I ask you what's the coordinates of turning point, right, just remember, make the square equal to 0. So x equals to -2. Well, y is 1. So that's the turning point. That is the minimum point because this curve is a U-shaped curve. Okay, so I'm going to make the question slightly harder. What about y equals to, this time is not x squared, but 2x squared plus x minus 3. So whenever there is a coefficient in front, the first step is you have to take it out. Right, take out the 2 from the first and the second term, but please leave the constant at the back. It's none of its business all the time whenever we're doing completing square. Okay, so since this become a half, right, don't forget this is still your 2ab term while your a is x, right? So the number I'm going to add is half of the half square. So I'm going to plus 1/4 squared. I add it, I minus it away immediately. I close the bracket, the original constant, leave it at the back. The next line is, I'm going to move this out of the bracket. So this is 2 times of x squared plus half x plus 1/4 squared. Okay, when you move it up, don't forget there is a 2 in front. So it's minus 2 times of 1/4 square minus 3. Therefore, this is 2 times of x plus 1/4 square. Okay, the constant at the back is minus 2 times 1/16, which is 1/8. Minus 3 means minus 3 and 1/8. So I'm done. So if I ask you, can you find the coordinates of the turning point? That will be a negative 1/4 as well as a negative 3 and 1/8. Okay, so remember, you always need to plus a number that is half of the coefficient in the middle and square, right? I actually never square it out because the next line, you're going to factorize it anyway. The 1/4 is going to come down, right? Because it's a perfect square identity. So no point I write it as 1/16 and later I have to square root it anyway, right? So that will be the second level when the coefficient is not 1. Okay, so I'm going to make it even harder. How about y equals to negative 3x squared minus 2x minus 1. This time, the coefficient of x squared is negative. Even if it's negative, I still have to take it out. And whenever I take it out, right, once again, leave the constant at the back. It's none of its business. So you decide what number to add. It's always half of the coefficient in the middle. So half of 2/3, that's a 1/3. So I plus 1/3 square, I minus 1/3 square immediately. I close the bracket, original constant, copy at the back. Right, so your aim is shift this term out, but don't forget there is a negative 3 in front. Right, so in the end, this is negative 3 times of x squared plus 2/3 x plus 1/3 square. Okay, so be careful. Negative 3 times negative 1 become plus 3 times of 1/3 square. Okay, minus a 1. So this is negative 3 times of x plus 1/3 square. Okay, plus another 1/3 and minus 1, that's a minus 2/3. So I'm done. All right, so the turning point, once again, is still make the square 0. So what happened is it's still minus 1/3. Okay, 0 minus 2/3, that's minus 2/3. But this time, this point is actually a maximum point, right? Because the coefficient of x squared, the leading coefficient is negative. This curve is an inverted U-shaped curve, right? So the turning point is actually a maximum point in this case. So this, I will say, are the 3 basic levels of completing a square, right? You must be able to master. So you follow the SOP, always take out the coefficient of x squared, decide what number to add, you add it, you minus it immediately, right, in the bracket. Always leave the original constant at the back because it's none of its business. Then you slowly factorize it. You will be able to rewrite expression in completed squared form. Sometimes you call it the vertex form as well, right? So once you rewrite it, you can actually figure out what is the coordinates of the turning point from the expression itself. All right, so these are the 3 basic levels. So now I'm going to extend it a little bit. What if I give you something like this? All right, so this time I'm going to give you an expression y equals to negative x squared plus 4x plus c. I anyhow cook up some expression, okay? So I tell you the maximum value of the y is 1. Can you find the value of c? Okay, so a lot of students, when they see this question, right, because of the c, they would think of the discriminant, right? Because discriminant usually has some k, some c, some n, and p in the coefficient, right? But this question is definitely a completing the square question because of the word maximum, right? Completing the square help us to find out the turning point, right? So maximum, minimum, this is when turning point is in concern. Immediately, I need to identify this question is a completing the square question, and there is an unknown in the expression, right? So let's do the same thing. Y equals to, take out whichever coefficient that x squared has, right? So minus 4x. So I decide what number to add. I plus a 2 square, I minus 2 square. The original constant, you keep it at the back. So even there's a c, never mind. I will still perform my completing the square accordingly. So this is negative x squared minus 4x plus 2 square. I shift the other 2 square out, it becomes plus 2 square plus c. So this is negative x minus 2 square, okay, plus a 4 plus c. So if I ask you to find out the coordinates of the turning point, it's still 2, 4 plus c, right? So the constant at the back is the y coordinate. Some of the question tell you the maximum value is 1, which means the y coordinate of the turning point is 1. So I can safely say, okay, 4 plus c should be 1. So c is -3. Right, so this is like the fourth level of completing the square, where there's some other unknown in the coefficient, but we still do the same thing. Can you see the procedure is very nice, it's very universal. You can apply it anywhere whenever you're doing completing the square. Okay, so now I'm going to make it even harder. So this is a question that was tested in 2016 from one of the IP school. I adapt it a little bit and make it simpler. Let's do it together. So once again, right, is the keyword maximum. That suggests to me that this question is a completing the square question. I tell you the maximum value is 2, find the value of k. So in terms of principle, these two questions actually are the same, right? But it is a lot harder to do completing the square for this expression because it looks really complicated. Let's give it a try. So step 1, let's expand it. All right, so I have to write it in ax squared plus bx plus c. So my c is k minus 4, basically. Right, so let's start the completing the square process. So step 1, take out whichever coefficient x squared has. So I have x squared. Be careful with the second term. It becomes 8 over kx. Okay, so the constant I need to add is half of this coefficient. So half of 8 over k is a 4 over k. So I need to plus 4 over k squared. I add it, I minus it away immediately. So original constant, copy at the back. So even if there's k, doesn't matter. I still decide what is half of this coefficient and I square it. So let me quickly move the very last term out of the bracket. Okay, so this is still plus 4 over k squared. Okay, I close the bracket, minus a k times of 4 over k squared plus k minus 4. Okay, so this is k times of x plus 4 over k squared. Okay, let me simplify a bit. This is a minus 16 over k plus k minus 4. All right, so I finished my completing square. So I can see my coordinates of turning point very nicely. So this question tells you the maximum value is 2, which means the constant at the back equals 2. So let's stop it. Negative 16 over k plus k minus 4 equals to 2. Right, this is a typical quadratic equation. So let me quickly move everything to the left. And I'm going to multiply k throughout and rewrite expression in order. Right, so clearly it is factorizable. So k minus 8, k plus 2. So I obtain two possible solutions, k equals 8 or k equals -2. So a lot of people very happily leave the answer like this, but that's not the end. There's one key word I want you to pay attention. That is, this question says the curve has a maximal value. Maximal value means the curve must be inverted U shape, right? Which means the coefficient of x squared must be negative for this curve to have a maximum point. Therefore, k as the coefficient of x squared must be negative in this case. So it's good that we write some reason, right? So I will say since that is a maximum value, my coefficient of x squared, k must be negative. So in this case, we have to reject k equals to 8. So I will reject k equals to 8. So the final answer will be k equals to -2. All right, so this question is really hard because number one, a lot of people didn't even realize it is a completing the square question. They mistook this as a discriminant question. Well, discriminant is not able to help you solve this. Okay, so whenever you see keywords such as maximum, minimum, highest point, lowest point, so on and so forth, please remember this is completing a square. Even if there's unknown k, right, m or n or t, some other letters in the coefficient, you are still able to do completing the square if you follow the procedure, right? Always take out the coefficient of x squared first, leave the original constant at the back, decide what number to add, you add it, you minus it away to make it fair, right? Then you slowly shift the bracket out and factorize the rest, right? It should be fine, right? So practice this procedure that will help you with complete the square in general. And this is really a very important technique that we're going to use all the way until A level. So please work on it. Okay, so that's all for today. Thank you for watching.